Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Mariam Rafique. Today we're gonna discuss chapter number 18, that is current electricity. Before getting into the core concepts of this chapter, I would like to share some learning outcomes so that by the end of this lecture, you will be able to understand that what is cell in physics, simple circuits, some symbols of circuits, series and parallel circuits, the concept of voltage, and some assignment questions. Students, in our previous lecture, we studied and come to know about some concepts regarding current electricity. For example, what is current, the direction of the current measuring device, we call it ammeter, and the concept of I is equal to Q times T expression, and EMF. Now I would like to share the concept of voltage here. So voltage is a force that pushes, or you can say drives, the electrons or charges. And it is also referred to as electromotive force or difference in potential. It is abbreviated as E, or you can say EMF, measured in volts. And voltage source will have a polarity, negative and positive. Current flows from negative to positive. You can say the changing conventions. And for the furthermore concepts of cell, I would like to recall the definition of electromotive force that we studied in our previous lecture. That was, in a cell or battery, the chemical changes takes place which provide the energy required to push the electric charge, or you can say the electrons, around the circuit. So I hope that now you are clear about the electromotive force concept and the voltage term concept. But in electromotive force, we use this term cell, or you can say battery. So first we have to understand that what is cell or battery. So by definition, the cell stores chemical energy and transfers it to electrical energy when a circuit is connected. Now students, an electrical cell is an electrical power supply actually, and it converts stored chemical energy into electrical potential energy, and allowing a circuit, or you can say the current in the circuit, to flow from the positive terminal to the negative one via an external circuit. And the positive terminal is called a cathode and the negative terminal is called an anode. So this current can be thought of as the flow of positive charges, even though it is usually electrons which have negative charge that carry current in a copper wire circuit. You know that. So since the current is the flow of positive charge, the negative electrons flow in the opposite direction to this. You can say the conventional current. So within the cell itself, the charge flows from the negative terminal to the positive terminal as it gains electrical energy. And when two or more cells are connected together, we call this a battery, and the cell's chemical energy is used up pushing a current around a circuit. So this is the whole story of the cell. Now we have to see some simple circuits. So what actually circuit is? In physics, or in electronics you can say that a circuit is a path between two or more points along which an electrical current can be carried. And you might heard this term many times, the circuit breaker. So what is a circuit breaker? That is a device that interrupts the path when necessary to protect other devices attached to the circuit. For example, in case of a power surge, you can say. So here is a simple electric circuit in front of you. It has a cell, a lamp, and a switch. The label diagram you can see here. And to make the circuit, these components are connected together with metal connecting wires. Now students, when the switch is closed, the lamp lights up. This is because there is a continuous path of metal for the electric current to flow around. And if there were any breaks in the circuit, the current could not flow. Scientists usually draw the electric circuits using symbols. You can see here a circuit diagram that is drawn by using symbols. So you can see easily that there is a replacement of a cell by a proper symbol, a lamp, switch, and as well as wires. So in circuit diagrams, components are represented by the following symbols. There are some of the symbols that I represent in front of you. For example, cell, battery, switch, lamp, buzzer, ammeter, voltmeter, motor, resistor, and some variable resistor. Now students, there are two types of circuit. Number one is series circuit and number two is parallel circuit. First, we have to see that what is series circuit. You can see the diagrams in front of you, the symbolic diagram and a simple diagram of a series circuit. So the components are connected end to end, one after the other. They make a simple loop for the current to flow round. And if one bulb blows, it breaks the whole circuit and all the bulbs go out. While in parallel circuits, the components are connected side by side. The current has a choice of routes. And if one bulb blows, there is still be a complete circuit to other bulb, so it stays alight. Now, measuring of current. You know that we can measure current by using a device that is called ammeter. And here is the symbolic diagram of ammeter, and that is connected in series with the circuit. So we will see here that this is how we draw an ammeter in a circuit. You can see both the circuit in front of you. You can see the comparison, the series and the parallel circuit. And the ammeter is placed in series circuit, while in the parallel circuit, the ammeter is placed before the lamps that are arranged in parallel settlement. Here I also want to add some information that in a series circuit, the current that flows through each of the component is the same, and the voltage across the circuit is the sum of the individual voltage drops across each component. while in a parallel circuit, it has two or more paths of current to flow through. So voltage is the same across each component of the parallel circuit, and the sum of the currents through each path is equal to the total current that flows from the source. And here we can see the same thing in a practical way, that in a series circuit, current is the same, you can say 2 amperes, at all the points in the circuit. While in parallel circuit, you can see that current is shared between the components. So 2 amperes actually shared between the two roots of the current, and each root is having 1 ampere. Now here is a circuit. You can say that copy the following circuits and fill in the missing ammeter readings, but I also add the missing readings here, but you can see it properly that how current will flow in series and parallel. Now measuring voltages. The electrical push which the cell gives to the current is called the voltage, as we have studied earlier in this lecture in the very start, and it is measured in volts on a voltmeter. Here you can see the voltmeter. This is a digital voltmeter, and here is the symbol of the voltmeter. So different cells produce different voltages, and the bigger the voltage supplied by the cell, the bigger the current will be. Unlike an ammeter, a voltmeter is connected across the components, and scientists usually use the term potential difference, or you can say PD, when they talk about voltage. And this is how we draw a voltmeter in a circuit. You can see here in the series circuit as well as in the parallel circuit in comparison. Now you will observe that the voltmeter is placed with the bulb in different arrangements. Now voltage is shared between the components. You can see that the battery is having 3 volt. This is a series circuit, and you can see that each component is having the half of the total voltage, like 1.5 volt and 1.5 volt. It will become 3 volts altogether. While voltage is the same in all parts of the circuit, and this is parallel circuit. You can see that there are 2 roots, and in each root and each component 3 volts are same. So voltage will be same in the parallel circuit of the individual component. Now this is the time for assignment, students. A think pair share is here. First you have to do what? You have to measuring the current and the voltage. Copy the following circuits on the next 2 slides and complete the missing current and voltage readings. Remember the rules for current and voltage in series and parallel circuits. And here is the first circuit, the second circuit. Thank you so much and good luck.